Hi, my name is Majeed, and in this video I will be presenting our paper about CodeAid, an LLM-based programming assistant that balances student and educator needs. As more students are becoming interested in learning how to code, programming classes are expanding. This makes it increasingly challenging to provide immediate assistance to students when they need help. Traditionally, office hours are often poorly utilized and not equitable. Therefore, we need alternative solutions that are scalable, equitable, and student-friendly. Currently, AI tools based on large language models like ChatGPT can help students by explaining, generating, and even fixing students' code at any time of the day for any student. But LLMs generate direct solutions, which might prevent critical learning, and their pervasiveness is concerning, particularly in academic integrity and student over-reliance. Therefore, we developed CodeAid as a Q&A programming assistant that balances generating helpful and correct solutions while not directly revealing code. CodeAid was built with 5 main features: general question to ask high-level programming questions such as inquiries about a specific function or concept, question from code to ask specific questions from a given code, explain code to provide detailed explanations, help fix code for debugging and identifying issues, and help write code to assist students in writing code. To ask a question using CodeAid, students simply need to type their questions and provide relevant context such as code, and CodeAid will immediately start streaming a response that includes multiple interactive components. They can read the AI's natural language explanation, go through a generated pseudo-code and understand how it works by hovering over each line, and see documentations for functions relevant to the student's inquiry. The general question, question from code, and help write code features generate responses that include a natural language answer to the student's question, the pseudocode of the specification they requested or an example code relevant to their question, function documentations relevant to their question and that are retrieved by the AI and not generated, and the ability to ask follow-up questions to further clarify the AI's response. The Help Fix Code feature responds back a natural language description of fixes that students need to do and highlights specific lines in their buggy code with suggested corrections, without directly showing them the fixed version. The Explain Code feature produces an interface for the student to hover over each line to see an explanation about what each line is doing and why is it needed. A summary of the entire behavior is also provided. We deployed CodeAid as an optional and additional resource in a class of 700 students for their entire 12-week semester. Using ChatGPT was not allowed in this class. We wanted to answer 4 main research questions in our deployment. First, what were students' usage patterns in terms of frequency, choice of features, and the nature of questions they were asking? Second, how was CodeAid's response quality in terms of correctness, helpfulness, and not revealing direct code solutions? Third, what were students' perspectives about CodeAid, its perceived utility and comparative advantages over existing resources including ChatGPT? And lastly, what were the perspectives of educators about CodeAid in terms of effective pedagogy and curriculum integration? We collected data from 5 main sources: weekly surveys that asked about students' usage of various resources, why they used and not used CodeAid, and what they liked or disliked about it. CodeAid's embedded feedback mechanism for each response, semi-structured interviews with 22 students, a final survey about their usage of CodeAid compared to ChatGPT, and 8 interviews with computing educators. In terms of results, we first look into questions asked from CodeAid and our thematic analysis on them. Throughout the semester, 372 students used CodeAid frequently and asked about 8,000 original questions. Around 160 students used it less than 10 times, while 62 students used it more than 30 times. Women used CodeAid significantly more than men, while representing only 30% of the entire class. The most frequently used feature was the general question, followed by ask question from code and help fix code, whereas the explain code and help write code features were used considerably less. A thematic analysis of nearly 2,000 inputs to CodeAid showed that students used CodeAid to ask programming questions, debug code, write code, and explain code. When asking programming questions, students mostly used CodeAid to ask conceptual questions about syntax, pointers, string operations, and so on, followed by asking about the behavior, arguments, and return types of specific functions. However, somehow unexpectedly, sometimes students use CodeAid similar to a compiler to verify execution or evaluate their code on particular inputs. For debugging, students predominantly used CodeAid to help them fix their buggy codes. However, they also use it in less direct ways to identify the source of their errors or to interpret and encountered error messages. When using CodeAid to help writing code, in about half of the cases, students asked how-to questions about a specific task. In the other half, they were asking CodeAid to generate their direct code solution, such as copying the task description. On explaining code, students mainly used CodeAid to explain the starter codes provided in their assignments. Now, in terms of the quality of CodeAid's responses, we looked at its log data and our thematic analysis of the responses. Overall, about 80% of the analyzed responses were correct. However, the correctness of features varied significantly, with the general question, explain, and help write code features all responding correctly in 90% of the times, while the help fix code and question from code being correct only about 60% of times. In terms of not revealing direct code solutions, as instructed, CodeAid almost never revealed code solutions. Instead, it produced natural language responses, pseudo-code, and suggested fixes. Now we turn into the student interviews and surveys to understand their perspectives about CodeAid and its comparative advantages. A recurring theme was how students appreciated CodeAid's 24/7 availability and being a private space to ask questions without being judged. Students also appreciated CodeAid's contextual assistance, which provided a faster way to access relevant knowledge, be able to phrase questions however they want, and produce responses that were relevant to their course. When asked about learning, students reported that responses were deep and clear. However, some students indicated that they wanted indirect responses like hints, particularly when using CodeAid to debug code. Interestingly, some students regulated themselves to not use features that produced more direct responses. In terms of trust, reviews were mixed. Some students trusted CodeAid and others found that it can lie to you and still sound confident. We found that being part of the course and the instructor's endorsement also increased trust, as one student said that they trusted CodeAid even more than Google just because it was part of the course. When we asked students why they did not use CodeAid, the primary reason was a perceived lack of need, followed by their preference to using existing tools and wanting to solve problems by themselves, or just had a general lack of trust over AI. In the final anonymous survey, we asked students to compare CodeAid with ChatGPT. Although ChatGPT was banned, students used it slightly more than CodeAid. They preferred its easier interface and larger context window to ask about longer code snippets. However, some students did not like that ChatGPT did a lot of the work for them. Now, to understand how other educators would use CodeAid and integrate it into their curriculum, we interviewed 8 computing educators. Overall, most educators like the integration of pseudocode with line-by-line explanations, as it provides structure and reduces cognitive load, and is better than finding exact code solutions on the web. However, some educators were concerned that when the algorithm is what students need to learn, revealing its pseudocode will be harmful to their learning. Additionally, since most educators found access to ChatGPT to be harmful for introductory level programming courses, they wanted to keep students away from it. For that, they would rather encourage students to use CodeAid, and suggested integrating an editor with code execution so students would work on their tasks right inside CodeAid. Educators also wanted the ability to customize CodeAid, such as when to display pseudocode and update it with course topics. Lastly, most educators wanted a monitoring dashboard to see a summary of asked questions and generated responses, and to reflect on their own instruction. However, educators also mentioned that students should not feel like they are being watched. Now let's look beyond CodeAid. Our results and experience developing CodeAid enable us to propose design considerations for AI coding assistance in educational contexts. We identified 4 major design considerations, each positioned with a student's help-seeking process with an AI assistant. First, how does a learner know when to use an AI assistant? This requires clearly exploiting the unique advantages of AI over non-AI tools. Once a student has decided to use an AI assistant, how should the input be designed to balance user-friendliness and metacognitive engagement? Third, how direct should the AI respond? How should it balance between students' productivity and learning engagement? And finally, how to support students in validating AI's responses. With that, I would like to conclude this presentation. Please read our paper for more details about CodeAid, its iterative development, and how our results point to specific directions in the design of future pedagogical AI assistants. I would also like to thank all my collaborators, especially Professor Michelle Craig for initiating this project and my PhD supervisor, Professor Tovi Grossman. Thank you all for watching.